Polynomials, that is our topic of discussion in this tutorial. And by the end of this tutorial, we should know really well what is a polynomial versus what is not a polynomial. Okay, what are the terms of a polynomial, the degree, the constant and coefficient, and what are various types of polynomial. Okay, so we have a lot to discuss today. Let us begin by writing a very general example. So my first example is 7x cubed minus 2x squared plus 5x minus 3. So one critical component of this expression is what is known as a variable. Variable are components of this expression that do not have any specific value. That means they can vary in their value and hence they are called variables, right? So x cube or x square, x, all of these are variables, right? But we will say that all of them have only one single variable, that is x. The only difference is what is known as the exponent of these variables, such as 3 in this x, and there is an exponent of 2, and then there is an exponent of 1 here, because when you do not have any exponent defined, that means by default the power is 1, right? So we will write here that the second component of this expression is what is known as exponent, right? An exponent in a polynomial is a non-negative integer. Okay, and that is what it makes it different from what is not a polynomial. We will come to that point a little bit later, okay? And the third component of this expression is what is known as the coefficient. Coefficients are all the numbers that are in direct multiplication with the variable, such as 7 or -2, right? You don't ignore the negative sign in front of this constant number that you have, right? That is why we say that -2 is a coefficient of the term x square, right? Likewise, we have 5. Whenever we are not defining the sign value, that means by default it is considered as a positive value, right? And then you will also say that there is a term -3. We can call -3 as a constant, or we could also call this as a coefficient. You could convert it either way. If you were to call it a constant, you say that there is no variable. But what if I put a variable x here and raise it to the power 0? It would not change the value of this expression at all. But you could always write it like this, right? So it would not be wrong to call it either a coefficient of -3 that has a variable x to the power 0, or you will call it as simply a constant. So these are various components of an expression, and this is what makes this expression a polynomial, right? The word poly means many, and there are a variety of components in this expression. Hence, we say that it is a polynomial. Now, you have understood what is a polynomial. Then how do you explain what is not a polynomial? Okay, so what if I rewrite this whole expression, but I change only one little thing? So let me write it here. What if I write here as 7x to the power -3, and I keep everything else the same? It is -2x squared plus 5x minus 3, right? The only thing I changed is instead of the positive power 3, I change it to -3, okay? And the moment I do this, I will say that now this becomes as not a polynomial. Why? Because these exponents, they always have to be non-negative integers. This is the critical word that makes the distinction between a polynomial versus not a polynomial, okay? So let's say instead of changing it to -3, what if I change it to 7x to the power 1/2 minus 2x to the power 2 plus 5x to the power 1/2 minus 3. And then let me write one more example. In this case, I'm writing 7x to the power y minus 2x to the power 2 plus 5x to the power 1 minus 3. Okay. So I will say all three of them are examples of what we will call them as not polynomials. Okay. Because in the case of this example number B, let's say this is an A. I have raised a power of 1/2 on x, right? And we wanted our exponents always to be non-negative integers, but this is a fraction. Hence, it is not a polynomial, right? Likewise, in the case of example number C, we say that 7x to the power y, right? Now, this is not an integer. This is a variable, right? So whenever you have a variable in the exponent, then we say that this is not a polynomial, right? So these three are very simple examples that will tell you how to differentiate between a polynomial versus non-polynomial, right? When you see in negative integers or fractions or a power that is in variable, then you say that this is not a polynomial, as simple as that. So now we would like to learn few more things that are in reference to polynomials. What you see here are 4 different examples of polynomials, okay? When we look at example number D, we say that the polynomial in D contains 4 different components. It has the first component x to the power 6, the second component is negative 7 x to the power 5, and then 3x squared and negative 9. So these 4 parts, each part is called a term, right? So a term in a polynomial is a part that can be separated by a mathematical operator, and that part could be either a constant or a product of a constant with a variable, right? So by that logic, we will say that the polynomial in D contains 4 terms, okay? Now you will also notice that there are different exponents in this polynomial. The highest exponent is 6, okay? And the highest exponent in any polynomial defines what is known as the degree of a polynomial, right? So this polynomial is of degree 6, right? So with that logic, when I look at my example number E, in this case, I see that there are 3 different terms. The first term is 5x cubed, negative 3x squared is second, and then constant is 6, okay? So with that, we will say that this has 3 terms, right? But the highest power in this polynomial is of order of 3, right? So we will say that this polynomial is of degree 3. And then we look at my example number F. In this one, you have only 2 terms, right? 3x and negative 2. So we will say that this polynomial is of 2 terms, and the highest degree is of what? In this case, we will say that it is of degree 1 because the exponent on x is just 1, right? And the last example contains only one single term, right? And then it has a degree of 0. Because you could always write that 9 is in multiplication with x to the power 0. Hence it is of degree 0, right? Now this gives you an idea of what are terms in a polynomial and what is the meaning of word degree of a polynomial, right? And you could always define that depending on how many terms are in a polynomial, you could assign a unique name to it, right? A polynomial with just one term is called a monomial. We have also studied about that in the discussion of expressions previously, right? A polynomial with 2 terms is called a binomial, right? A polynomial with 3 terms is called a trinomial. And a polynomial with more than 3 terms such as 4 or 5 or 6 is simply called a polynomial just by itself. Only thing is that up to the 3 terms, we have a unique name assigned, monomial, binomial, or a trinomial, okay? With that, we will say that we have covered all of our learning objectives. We have understood what is the difference between a polynomial versus not a polynomial. We have also covered about understanding of the terms and degree of a polynomial, and then we have looked at what is the difference between a constant and coefficient, and then finally we have looked at what are the various types of polynomial. So this was our learning objective, and we will proceed on to our next tutorial on where we will have a little bit more understanding on how to operate on polynomials.